Today's topic is second law of thermodynamics. First we see what is the need of second law of thermodynamics. First law of thermodynamics is one form of energy conservation law, and according to it heat can be converted into work. This law does not give information about the limit up to which heat can be converted into work. This law also provides no information about the direction of heat flow. This is why we need second law of thermodynamics. There are two main statements of second law of thermodynamics. One is Kelvin-Planck's statement and other is Clausius' statement. According to Kelvin-Planck statement, for any engine it is impossible to work continuously by extracting heat from source and rejecting no heat to sink. In other words, we can say that 100% efficient heat engine is impossible. Since efficiency will be 100%, that is 1, when no heat is rejected to sink. So according to Kelvin-Planck statement, this type of heat engine is not possible, which extract heat from source and convert all that heat into work and gives no heat to sink. This is 100% efficient heat engine because it convert entire heat into work. If it extract Q1 heat from heat source at temperature T1 degree and gives no heat to sink at temperature T2 degree and convert entire heat Q1 into work, W equal to Q1, and Q2 here is 0. Then efficiency is 1, that is 100%. So according to Kelvin-Planck statement, such engine which extract heat from source and convert entire heat into work by giving no heat into sink is this type of engine is not possible. Second statement is Clausius statement. According to Clausius statement, for any self-acting machine it is impossible to transfer heat from a body of low temperature to a body of high temperature. So it is not possible that heat flows from low temperature to high temperature. In other words, we can say that heat cannot flow from a body of low temperature to a body of high temperature, or we can say that 100% efficient refrigerator is impossible. So according to Clausius statement, it is not possible that some self-acting machine extract heat from low temperature sink and gives it to high temperature source. Here we see that this is refrigerator. If a heat engine works in reverse direction, it works as refrigerator. This refrigerator R extract Q2 heat from sink of low temperature T2 degree Kelvin and gives entire heat Q2 to source of high temperature T1 degree Kelvin, and no work is done on it by self-acting machine. We mean that no work will be done on it, and this shows that Q2 heat goes from low temperature to high temperature and no work is required for it. Such an machine is not possible according to Clausius statement. Now we can prove that both the statements are equivalent to each other. If we assume one statement is wrong, then we can see that second statement also becomes wrong. First, we assume that Clausius statement is wrong and a 100% efficient refrigerator R is possible, which extract heat Q2 from sink of low temperature T2 degree Kelvin and reject it to source of high temperature T1 degree Kelvin, and there is no need to work on it. If this is possible, heat Q2 is taken from sink of low temperature T2 degree Kelvin, and this heat Q2 is given to source of high temperature T1 degree Kelvin. That is, Q2 heat flows from low temperature sink to high temperature source. If this is possible, that is, Clausius statement is wrong, then we use a heat engine E which works between the same source and sink, and this heat engine E extracts Q1 heat from source of T1 degree Kelvin. It gives Q2 heat to sink at T2 degree Kelvin, and the remaining heat Q1 minus Q2 is converted into work. So work done by this engine E is W equal to Q1 minus Q2. So we assume that Clausius statement is wrong. Such an 100% efficient refrigerator is possible, which extract Q2 heat from sink and gives it to source. That is, heat Q2 flows from low temperature to high temperature and no work is required for it. We connect a engine between the same source and sink. Now we see the combined effect of these refrigerator and heat engine. First, we see what is the combined effect at sink. At sink, we see that Q2 heat is given and Q2 heat is taken. So, we can say that no heat is given to sink, heat given to the sink is 0 and heat taken by it is 0. There is no effect on sink. Q2 is given to it and Q2 is taken from it. At source, what is the combined effect? Q1 heat is taken from it and Q2 heat is given to it. Q1 is greater than Q2. Then we see that effectively Q1 minus Q2 heat is taken from the source and no heat is given to sink, and work done W is equal to Q1 minus Q2. So Q1 minus Q2 heat is taken from source, no heat is given to sink, and entire Q1 minus Q2 heat is converted into work. So the combined effect is this, that it is 100% efficient engine which takes Q1 minus Q2 heat from source and gives no heat to sink and convert entire heat into work. This violates the Kelvin-Planck statement of second law of thermodynamics. So if Clausius statement is wrong, then Kelvin-Planck statement will also becomes wrong. In second part, we assume that Kelvin-Planck statement is wrong. That is, such type of engine E is possible which extracts Q1 heat from source, it gives no heat to sink and convert entire heat Q1 into work. So work done by this engine is W equal to Q1. Now we connect a refrigerator R between the same source and sink. This refrigerator R works by this work W done by heat engine E. So work done on refrigerator is W equal to Q1. If it extract heat Q2 from sink, then heat given to source will becomes Q1 plus Q2. Now this is a self-acting machine. Work is done by heat engine and this work is used by refrigerator R. There is no external work done on this entire machine. Now we see what is the combined effect. Combined effect at sink is that Q2 heat is extracted from it. Combined effect at source is Q1 plus Q2 heat is given to it and Q1 heat is extracted from it. So net effect is that Q2 heat is given to source. So entire effect is that Q2 heat is extracted from sink and Q2 heat is given to source and no external work is required. So it means that heat Q2 flows from low temperature sink to high temperature source and no external work is required, which violates the Clausius statement. So if Kelvin-Planck statement is wrong, then Clausius statement is also wrong. So we see that both the two statements of second law of thermodynamics, that are Kelvin-Planck statement and Clausius statement, these two statements are equivalent to each other.